How do the devices in our lives actually talk to each other? A computer or a phone sitting completely isolated on a desk is practically a paperweight. Without a way to move data in or out, it can't update, it can't stream, and it can't message anyone. We call these starting units end devices, whether it is a laptop or a smartphone or a wireless printer. An end device is the ultimate originator or receiver of digital information. To get that data moving, you might think you could just run a physical cable from your laptop directly to every other device you want to talk to. But multiplying that across billions of devices worldwide is a logistical impossibility. The solution is a carefully assembled ecosystem of specialized hardware. Instead of a messy pile of point-to-point wires, these devices are designed to route data cleanly and efficiently from origin to destination. The first piece of that specialized hardware solves the local cable mess. We call it a switch, and it acts as a central connection hub for wired devices within a single building. Watch tangled connections disappear into a clean star layout. A switch connects local devices. Inside, it uses a MAC address to memorize which computer connects to which port, routing a laptop's data directly to the correct printer. Of course, walking around an office with a physical Ethernet cord trailing behind your phone is completely impractical. That is where an access point comes in. It provides a wireless doorway, allowing mobile devices to connect into that same wired local network over radio waves. For this hardware, the rule is an access point provides wireless access. Switches and access points do an excellent job of organizing a local area network, but they are completely blind to the outside world. They lack the map to send data outside their own building. So, what happens when your local laptop needs to pull a web page from a completely different network halfway across the world? That job falls to the router. The router is the network's intelligent GPS, responsible for navigating traffic between entirely different networks using an assigned location label called an IP address. A router sits between two local networks. It calculates paths using an IP address. Because a router connects networks, to reach the wider web, it passes data to a modem, bridging the gap to your internet service provider. Opening a door to the internet means anyone can walk through it. Traffic cannot simply flow in and out unmonitored. We place a firewall at the internal network's border. Watch the firewall barrier stop red malicious packets while letting green ones pass. The rule is simple. A firewall protects traffic. Reaching the internet requires balancing open access with strict control. The router finds the path outward, and the firewall decides who is allowed to take it. When our data successfully and securely crosses the internet, what machine is it actually trying to reach on the other side? It is looking for a server. Whether sitting in an office closet or a massive warehouse-sized data center, a server is a high-powered machine dedicated to providing files, running complex applications, or hosting websites. As you can see in this infographic, the rule is simple. A server provides services. Despite the heavy-duty hardware, servers are really just specialized end devices waiting to answer the requests generated by our personal laptops and phones. Without servers, the massive global infrastructure of switches, routers, and firewalls would simply be empty roads with no final destination. We can see the complete picture when we bring all these isolated parts together into a single cohesive ecosystem. Let's map the flow of data from the outside in. Starting from the vast internet cloud, traffic hits a firewall, which connects to a router, which then feeds into a local switch. Branching off that switch, we add an access point for wireless coverage. Finally, we populate our end devices, a laptop and phone connected to the access point, and a local server and printer plugged directly into the switch. The entire chain works together. Switches connect devices, routers connect networks, access points connect wireless users, firewalls protect the network, and servers provide services. That is the foundation of how modern networks are built.